So chapter 3, it's about SQL. We have actually 3 chapters on SQL in this book. 3, 4, 5. Okay, so one is the introduction, then is the intermediate, and third one is the advanced SQL. And we are going to see, because it's not possible to cover the whole SQL, it's not the objective of the course actually. But in general, SQL is a language which is very much, sought about, which means that there are some good jobs just for SQL if you have good experience in SQL, and if you do some projects or some sort of um, I would say practical work, okay, small projects related to SQL, then it is, there is a chance that you will get a good job on the basis of SQL. Same is true for pandas, okay, just panda alone. We did some basic things in pandas, but the advanced things like, grouping and pivot tables, which are very much, required skills, and not many people understand those skills, okay, they don't have expertise. So if you can somehow do, experiment with that, that will give you a good grip on both SQL as well as pandas. And third thing we also studied is the Microsoft SQL. Okay, so sorry, Microsoft Excel. So we know about Excel, what is Microsoft Excel, what we can do there, basic things. Again, there is the concept of pivot tables in Excel also. So I hope that we get a chance to see the pivot tables both in all the 3, in Microsoft Excel and in pandas and here in SQL. So you can compare, and then it will help you in deciding which tool is actually best for a given situation. In some simple situations, Excel may be the best choice because you can do things in a few minutes. Then a little bit complex is pandas, which gives you more flexibility, etc., as compared to Excel. And then there is SQL, which is a complete database system, which really is about advanced searching and indexing and very large databases. Okay, so if you are doing data science, usually you may not need SQL until certain limits, but beyond that, then you definitely need SQL. Okay, and that's why SQL is an important part of data science, databases, okay, data analytics, and even sometimes you can say machine learning. Okay, so before we go further, can you just have a look at it, and can you see what we have studied in chapter 1 and chapter 2? What we have studied is before you. Okay, in chapter 1 we studied the ideas of the basic introduction to databases. Okay, what is database, what is DBMS, we know about schemas. So we very briefly discussed the physical schema, okay, and then the logical schema, even if I didn't go into detail, okay, but it is there in the book, and we are going to repeat that throughout this course. So that's why I did not go into the detail of these things. Okay, so yes, what's your question? We know about chapter 2 also. So by now you should know about relational model and relational databases. You should know what is a relation. That's the basic thing, remember. Okay, so a relational model uses relation, and it's simple. A relation is equal to a group of attributes together. Okay, so for example, for a student, the relation may be the student name, the student age, the student ID, the student GPA, for example. That may be a relation, and it can contain even more information. Or we can have many more than one table related to student. So one may be about his course information, one may be about his scholarship information or fees information. Okay, the third table may be about his address and mobile phone and parents education, etc. Okay, so they are different relations, and a relational model is about relations. Okay, and similarly relational databases. So we have we studied example relations, we studied the schema and schema diagrams, etc. Okay, let's move towards the next slide, and we started this chapter. So what is the SQL? Okay, well, actually it is the structured query language. So SQL is query language. SQL itself stands for structured query language. What is SQL data definition? Basic query structure of SQL queries. Okay, how do we write queries? And what is a query? Can anyone tell me what is query? And what is data definition? Yes.
Data definition, it's a collected of information that if it was organized or not organized structure. About SQL, it's that language to deal with the data base to take information. So استدعاء. It's
Sorry, repeat. What is
استدعاء.
استدعاء? Yes. Okay. Request. Okay.
Request. Yes, request information from database. So
okay.
if
So
we
that
want
is query or that is SQL? What is query?
It's the same. Or
Yeah.
this
Okay.
application.
Actually. So query is, yes, a request to a database to get some information, okay,
yes,
or even to put some information into the
like
database.
a
Thank
language,
you.
like a language to communicate with computer.
Excellent. Yes. Okay. So it is a language to communicate with the databases, then you will say. Okay. So not only just communicate, but even to create, also delete things with the database. So everything related to database, we don't use the general programming languages like C, C++, Java, but we will use SQL, for example. SQL is one of the query languages. There can be other query languages like RDF has a query language. Okay. Sparkle is a query language. So they have different syntax and they are for different types of databases. So the most popular one for the relational database is the SQL. We can have other languages about relational database also, but this is the most powerful one, most popular one. Okay, and actually, the one which is like a standard in general query languages. Yes. So there is small history. I'm not going into the history, but it has some revision. Let's say from '86 until 2003, which is the current standard. Okay, and there are different implementations of SQL. Okay, and not all the implementations they may support the same operations. So there is a specification, and then there are different implementations of that specifications. So there might be some differences in the implementations, but most popular ones like MySQL and Microsoft SQL Server, etc., they support most of the important things. Okay, now what are the parts of SQL? We already know about DDL and DML. So DML, it provides the ability to query information from the database, okay, as I asked you before. So to query information from the database and do what? To insert tuples. Tuples is what? Is a relation. Okay, so why do we call it tuple? Because it can be a single value, it can be two values, it can be three, it can be 1,000 values, for example, in a single record. Okay, so to insert tuples into or delete tuples from and modify tuples in the database. So everything related to creating new, deleting existing ones, and modify the existing information, this is done by what? The DML, okay, data manipulation language. So this is about manipulation. Now manipulation does not contain things about what, like data definition, which is a different thing. Okay, so that's one thing. Then view definition, as I told you, that we define views of one table. You can define several views. So there is a big table with different columns with different attributes, and you have different database users. Okay, so one user may need one part of the table, another may need another part of the table. Let's say students table. Okay, so one user may need the course registration view. He may be able to, like the student himself, you may only be able to register your students, but the other view will be about dropping the course. Let's say you cannot drop your course, let's say. Okay, so there will be an advisor who can drop the course. Then there will be another view for the chairman who can do something else, for example. Okay, so there are different views of one table or more tables. Then transaction control. What is a transaction? Actually, maybe you have studied the definition of a transaction. So transaction is actually a set of different modifications, insertion, updation, deletion into the database, which should be taken as a single unit, which means that either you should complete all of them or you should complete not a single of them. If you complete only some and not all, then it may be an abnormal transaction and it may create an inconsistency in the database, or we will say that the integrity of the data will be lost, which was actually the second point. Integrity was here, I missed that. So the DDL includes commands for specifying integrity constraints. Now what are the integrity constraints? For example, registration number. What are the integrity constraints? We can say that it cannot be null, because if a student does not have a registration number, it means he doesn't exist. Similarly for name, okay, some things which cannot be null, or something which can have certain values. Okay, so those are the integrity constraints. We are going to study them. Then we have embedded SQL and dynamic SQL. Okay, it defines how the SQL statements can be embedded within general purpose programming language. And I will say that normally programming languages like Java, okay, they connect with databases through an SQL driver. We call it a driver. Just like when you have, a sound card in your computer, or your screen. So those hardware needs driver, okay, which is a piece of software to run that hardware. Similarly, there is a small piece of code which is known as a driver, which is used to connect to the SQL server or the SQL database and do the necessary things. So in those programming languages, there are different types of drivers. The most popular one used to be the ODBC, Open Database Connectivity. There was a driver which was available for different languages, even for Python, Java, etc. So you install that driver as part of your language as a library, okay? And then when you want to connect to SQL, so you will use the functions within that library. Okay, like in pandas, what functions do you remember for pandas? If you see, there was a function is null, is nan, for example, okay, or describe function, info functions. These were the functions from the pandas library for different purposes. Then finding max, finding minimum, these were the functions from the pandas library. Similarly, in the SQL, you know driver, it has some functions or many functions that you can use to actually connect with the database. So these functions will also execute the SQL queries that you will write in the SQL, and you will pass those queries to the functions, and the functions will execute those queries. Okay, we will see some example. Authorization includes commands for specifying access rights to relations and views. So who can access, or who can modify, who can view, who can delete, okay, who can change, let's say, different views or different relations, different tables. So you define the rights for different people. So the database management system, it contains the functionality to define different users, and for each of the users you give different types of permissions, what each user is supposed to do and can do, and what specific users cannot do. So the very first thing is the data definition language. It is about the specification of information about relations. So it is to specify something, to define something, okay? So what does the definition include? The definition includes the schema. And what is a schema? Actually, in the beginning, maybe you say that they all are almost same thing. There is data definition, then there is schema, and then there is data definition language, and they all talk about the same things. But when you are used to these reading as and then use it yourself, then you will understand. So schema is something which is not related to SQL, which is part of the table or part of the relation. Okay, and data definition language, it is part of the language. Okay, so there are two different things. One is table, which has a schema, and the other one is how you create the schema, which is done using the data definition language. So student has a schema. Okay, the schema contains what? What was the schema? The schema contains what are the different attributes in the table, what are the types of attributes. So for example, the name, it can be only string, it cannot contain numbers. So this is information in the schema that a student table has a name attribute, and the name can only be, let's say, string, and maybe we can say that the string cannot be null, and the string cannot be more than, for example, 20 or 30 characters. So things like these, okay, they are defined in the schema for each relation. The type of values associated with each attribute. What type of values? Then the integrity constraints I explained to you in the last slide. The set of indices to be maintained for each relation. Now index is an important term. Why do we use indexes? Because if we don't use index, okay, we store the table as it is, then it will take a long time to search for information. So index is actually a compact sort of dictionary which helps you in lookup of the important information. So how do you use a dictionary? If you talk about normal dictionary, okay, qamus, how do you use it? You know that, let's say, if I ask you to search for the definition of the word query, okay, query is a word, so you are not going to start from the first page. Okay, some dictionaries, they will give you some guide, so you can directly go to the queue, okay, because query starts from a queue, or you can just flip a few pages towards the middle or towards the end of the dictionary, and you will Maybe you go to S or you go to R, then you know if it is R or S, so you need to go back. So Q is before R and S. If it is around N, for example, you will know that Q is after N, so N, O, P, Q. So you will flip more pages. Then within the Q, you know that QU is the second thing, so you will not start from QA. If you fall upon QA, then you will flip many pages, okay, to go to QU and so on, okay. So the dictionary helps you in faster lookup of certain definitions. Same concept is in databases and many other software systems that you define dictionary or indices. An index gives you information. Now in books, actually, if you know about index in book, do you know, have you ever used an index in a book? I'm not talking about dictionary, I'm talking about any book. Okay, so what is the, you know, index, for example, where it is in the book? Is it in the beginning or is it at the end? So one thing is, you know, one thing is about table of contents. So the table of contents is the very first thing, okay, before the start of the book chapters, before the introduction, etc. There is a table of contents. Okay, so table of contents tell you that what is in each chapter, okay, what topics are in each chapter. That is the table of contents. But the index is the last thing in the book, okay. It is after exercises, etc., and the index tells you that what, you know, definitions or what word or term comes at which pages. So an index may contain, for example, if you go, it is like a dictionary, but it will just contain the name of, you know, the topic, let's say query, and then it will tell you, it will tell you that where is that topic, let's say page number 21 and page number 30 and page number 75. So all those pages, it is appended on design book. No, it's not design. At the end of the book you have the index, okay. Then we have appendix, and then we have also glossary, etc. There are many parts of a book, but index is something which gives you a quick reference of where to find something, okay, what are the possible locations of something. So that is the, you know, index. And we will discuss about indices, hopefully, that how do we create indices, what type of information they contain. Then you know, in data definition language we can define the security and authorization information for each relation. I discussed this also in the last slide. Security is that it should be secure from unauthorized access. And how do you secure? Because you define authorization policy, who can access what part. Then the physical storage structure of each relation on the disk. This is the last thing, okay. How do you structure that? So you have some possibility to define what type of structure, because maybe your data is related to, let's say, strings, maybe your data is related to integers, okay, maybe your data is related to videos and audios, etc. So they have their own different types of storage requirement or storage optimization or indices. So you can specify that. If you don't specify, let's say, okay, and you define a table, so the database management system knows what is the best option for that thing, and they will use that also, okay. If you are expert, then you can define the physical storage structure or the physical schema. Actually, the last thing is about physical schema, okay. So you know, we can see that how do we define views and schemas and the physical and logical both schema. Okay, domain types. So as you can see, more are covered in chapter 4. Chapter 3 does not focus on domain types. What are domain types? Domain type means what are the possible values for a certain attribute, okay. The possible values for certain attribute. For a student, the student name, the possible values are the alphabets, but not numbers. For age, you should only have numbers. You cannot, normally you are not even supposed to write 19.3, for example, okay. So if you want to write usually age, then you will have different years, different months, for example. And even as I told you before, that in hospitals, usually for children hospitals, they have also the unit of how old is 1 day or 2 day or 30 days. If it is more than 30 days, then it is 1 month, 2 months, 3 months, something like this, okay. And then if it is more than 1 year, then they say 1 year, 2 year, then after 12 years, then after that it continues with years, okay. So this is actually the domain. So what domain is allowed for each type, it depends. So character n, what is n? Actually it means that it can be n number, length n. fixed length character string with user specified length n. So you can specify character as, you know, what, n length. Then varchar n is variable length character string with user specified maximum length. Okay, so the character is fixed length. Okay, let's say you say character 10, so it will be fixed for 10 length. Let's say URID, if you accept that as a character, that may be 10, not more than 10. Varchar is maximum. So normally we use varchar for names because the maximum can be, for example, 20, but someone can have even small. For example, Ali. Ali is only 3, let's say, characters, but some have very long names, so we will have a variable character. Okay, then integer, type int, a finite subset of the integers that is machine dependent. Now integer can be actually, you know, let's say 4 bytes, 8 bytes, etc. But integer in general, it contains you know, positive number, negative number, zeros, and without decimal point. There is no decimal point. Okay, so these are really only integers. Small integers is the small integers, small int. Okay, infinite, infinite is part of the integer. No, infinite is a special value, I think. Okay, infinite is a special value. Normally we will say nan to denote infinite. Okay, so there we are talking about finite subset. Finite means which is a number which is countable. Okay, so it can be even 100 million, for example, or 1 million, but of course that is countable. It is not infinite, it is finite. So small integer is usually, you know, for example, 2 bytes, let's say, or 4 bytes. That is small numbers, because you may not need big integer in that. Let's say number of the price of book, okay, or, you know, the number of pages in a book. You don't need to store billions. It will be 100 or 1,000, a few thousand. Okay, not even in hundreds of thousands. So you will use small integer. Why do we use small integer? The reason is we don't want to waste memory. So the normal integer may, let's say, use 8 bytes, and small integer may use 4 bytes. So if you have hundreds of thousands of records, then it may save a large number of bytes if we use small integer, because we don't need integer. So that's also a good choice, that when your work can be done by the small integer, so you should not use the normal integer or the long integer. Okay, then you have numeric. Okay, example in 22. Okay, yes, what does that mean? Explain. Yes, integer, just an example. Even 0 is an integer, or your age 22, your age 30, anything can be an integer. Okay, now temperature usually cannot be an integer. The temperature is 37, 36.5. Why? Because it has actually point. So 37.2 should not be integer. It should be rather, you'll see there are two things, numeric and double. Okay, numeric is what? It has two parts, the numeric. One is the P and the other one is the D. So it has a fixed point number with user-defined precision of P digits, with D digits to the right of the decimal point. So when you say numeric 31, so it contains something like this, 44.5. Okay, so you have 3 before the points and only 1, for example, after the points. Okay, 3 means total. Okay, so 3 means the total one, so it means that 44.5 cannot be done, or 0.32 cannot be done. Why? Because after point you can have only 1, like 44.5 just. Okay, not 322. And this is also not good because they form 4. They are now 4 digits, but the total is allowed is, you know, 3 digits. So it means that temperature is better for numeric, and the best one is this one for temperature. Okay, the body temperature can be, let's say, 36.9, 37.1, 39.6, something like this. Okay, so that's best represented as numeric and not integer. Then there is real double precision. Okay, which is floating point and double precision floating point numbers with machine dependent precision. What does that mean? So they are decimal numbers, but they have better precision. Okay, so it can be a number something like 0.00059, for example. Okay, many zeros after decimals. So if this is not really very much precise, and just you can have something like 3-4 decimals, then real is enough. But if you want high precision for some very precise calculations, financial calculations, let's say you want, or you can see that some experiments like physics, etc., which require very small number, or even in machine learning, sometimes you may need small number of change. For example, in machine learning, deep learning algorithms, you change your parameters by a small value. So this small value can be as small as 10 power minus 6 or 10 power minus 7, for example. So you may need, let's say, double precision for that. Okay. Floating point number with users specified precision of at least n digits. Okay. So how much precision do you want? These are some domain types, or I can say the data types, which are available in the. So we know about the data. Now the first thing is to create a table. How do you create a table? Okay, so an SQL relation is defined using the create table command. Create table, and R means relation. Okay, so it can be the name of the table. So we just say R, but it can be any name, for example, student or teacher or patient, okay, or book or library, whatever it is. Okay, so you will create a table, and within the brackets you can see these parentheses. Okay, the parenthesis starts from here, and then they start and here you have A1 and D1. Okay, what is A1 and what is D1? A1 is the attribute name in the schema of relation, and AI and DI is the data type. Okay, so some attribute I with data type I. So attribute can be, for example, the ID of the student. The data type may be integer, let's say. Okay, or it can be that numeric. Okay, then A2 can be, for example, the age of student, let's say, and the data type of that will be integer, small integer, because the age cannot be more than 100, for example. Small integer will be sufficient, and so on. And then we also have different integrity constraints, as I explained, that for which type of attribute, what type of constraint do you want? Something cannot be null, something cannot be greater than or less than, something like this. Okay. Okay, here is an example. Can you see and understand, or is there any question on this example? So the ID is up to 5, in fact, fixed 5 characters. The name is up to 20 characters. The department name is up to 20 characters. And the salary we define as numeric. So it can have 2 decimal points and maximum of 8 digits, which means D is the type of data, yes or no. Yes, this is what I said. D is that domain we said. Okay, in the last thing we defined the domain. So what were the domain? The domain were these possible things. Okay, so it can be character, it can be virtual, etc., as we can see here. So we define create table. So instead of R, we write in structure. A1 is what? My ID, and D1 is what? Character 5. This is A2 name, and D2 is varchar, and so on. So I have up to A4 and D4. And here what we have is that we did not define the constraints, but there are different constraints. For example, so you can have one constraint which is known as the primary key. Okay, and we defined already the primary key, that it is the key that uniquely identifies each record, okay, in that table. Yes, Seham.
I want to say the foreign key, it's also primary key, but in another table.
Which key? Sorry, repeat.
Foreign key.
Foreign key. Foreign key. Foreign key.
Yeah, foreign key. It was primary key, but in another table.
It is the primary key of another table, which is used here. Yes. Okay, excellent. We will study that. Okay, so primary key is in one table. Okay, the same primary key, if it is used in the other table, that will be a foreign key. Okay, so primary key is for reference R, and the foreign key is again referencing R, but from another table. Okay, good. And let's say there is non-null. Okay, so it should not be null, for example. We can have these integrity constraints. So if you try to insert a record in which you, let's say, this is about the ID. So if you don't write the ID of the student and you try to insert, so it will give you error because the ID is not there. It is null. So it will give you an error. Now SQL prevents any update to the database that violates an integrity constraint. That's important thing. The importance of integrity constraint is that the SQL will not allow the database if it has a mukhalifa for integrity constraint. So always it will check the integrity constraints first before doing any update to the database. Okay. Now here is the example. You see all the same example, but we added integrity constraints at the end. So we added 2 integrity constraints. One, that in this table the ID is the primary key, And second, that the department name is actually a foreign key, which is coming from the department. So that department name is a primary key in the department table, and we are taking it here as a foreign key. So these are two integrity constraints. Okay. Okay, there are some more definitions. How do you create a student table with ID, name, department, total credit hours? Okay, this is al-ab'a, or what is called in Arabic al-aba, I think. Okay, total credit hours, and or al-uba, I don't know. Then there is primary key, ID, foreign key, references department. Okay, the same for student. And the third one is what? Takes. Okay, now this is interesting that this is not student course, but it's the takes table, which means that it is combining the student and the course. So some student takes a course, so this is a table between the student and the course, and we will know how to create these tables and why these tables are important when we design a database. Okay, so here we are talking about the primary key, and you can see the primary key consists of three or four things rather. Okay, the ID, the course ID, the section ID, the semester year, five things. There are five things in the primary key. So the primary key is combined of all of those except the grade. Okay, the first five attributes, they make the primary key in this table. Okay, why? Because even if you skip the year, for example, and you choose the four ones, it may not be defining, a student uniquely. Then foreign key ID is referencing from the student. Okay, so ID of a student is becoming the foreign key here. Okay, which is primary key in the student, and the foreign key, course ID, etc., they are from the section. So we combine the student and section into takes. Okay, let's take a break and we will start. This is further example. I give the chance to you to study it yourself. This is very simple. Okay, we are going to study updates to the table after a break of 15 minutes. Okay, if you have any questions, I have uploaded the lecture slides, so you can ask me after the. We know now how to create tables. Okay, first we studied the data types or the domains. Then we know how to create a table. That's the next type. Because you know the data type, you know your requirements for what type of attribute in which relation, what data type should be used. Now you can create the tables. And how do we update table? So what are some of the update operations? First is, you can see the example here is the insert. Okay, so what do you insert? It is in the instructor table, and these are the four values. So actually this, the second line, insert into instructor values, and then within the bracket you have four different values. It is actually SQL query. Okay, so a single SQL command, a simple command, insert and into, these are the keywords which must always be there. Like you cannot change it. If you want to insert, it must be there. Then instructor is what? It is the relation, the name of the relation. So it is the instructor relation or table. Values means that what follows are these values. So why do we have these four values? Because if you go to the instructor, remember these values. 10211. What is this? This is ID. And remember, these are 5 characters because the varchar 5, we had specified that. Okay, so that is the ID. Then this is the name. It can be up to 20. Then what was that? Was it course or what is subject? We are going to see that. And the last one is the salary. Okay, so if we go back to the instructor table, okay, which was, I think, the very first table. So there was the ID, the name, the department name. Yeah, so biology was the department name, and then there was salary. Okay, so these were the 4 attributes we require in the table. Yes, Asma.
Doctor, and the primary key, every table one or many? For one table.
Okay, from here, what do you see? Here in the instructor table, what's the primary key?
One.
Only the ID, only one attribute. Okay. Okay, what about here? What is the primary key of student? Again, it's only ID. What about this table, takes? What is the primary key?
ID.
No, they're the 5 ones here.
Yeah, yes, 5.
The primary key is the 5, the ID, the course ID, section ID, semester, and year. They all together, they make one primary key. Why we need 5? Because we will see that if you insert data into takes and the ID, let's say a student, we can repeat that, because for you, for example, you are taking, let's say, 5 courses, so your ID will be repeated. Your ID, okay, that will be repeated. Similarly, the course may be repeated for you. You may repeat a course. Yes, not more unique, but exactly unique. To make it unique, what are the attributes which will be unique? So the semester is going to be repeated for different students, because in one table there may be many students. Okay, so Siham may be taking in the same semester, in the same year, a course. So if I say just semester and year, like this is what, fall 2021. So this will be fall in 2021, and all of you will have the same fall in 2021. Similarly, the section ID is same for all of you. The course ID is same for all of you. It will be only that ID is different here. But again, if you take only ID, then maybe in the same table, on your ID, you have another course. So that will be only difference in the course ID. So you are taking, let's say, data science principles of data science. So the ID of you will be same, the section ID, semester. Okay, section ID will also be different in that case, because here we have different section for each course. So the section ID, course ID will be different, but the ID, the semester, and the year, they will be same. So maybe for our case, just even the section ID and the ID may be, let's say, unique. Because in Taif University, you know, the same course, if it is offered in the next semester, next year, it may have a different ID. Okay, so the ID and the section ID, they uniquely, they can define the takes. You understand this? It depends on the design, and when we actually design the database, we will see this aspect. Okay, so I hope you are you know, here the course ID only is just, you know, only one attribute which is taken as the primary key. So we understand these things. So that was the insert into instructor. Okay, so it is only one instructor with 4 values. If you want to add another instructor, let's say, you will add again the same statement, insert into instructor. The values will be different because it will be an instructor with a different name. Maybe the department is same, maybe salary is same, but at least the ID and the name, they will be different. Okay, so insert many things. We will repeat the same instruction again and again, and we are going to see that after the exam. When we actually do the practical SQL, we will see how to do that. Then the next thing is about, you know, remove all tuples from the student relation. Let's say you want to delete everything from the student, so there is delete from student. Okay, so that will delete it. Then drop table R means just remove the table totally. So here you will delete everything from the student, but the table will be there. If you say drop table student, it will completely delete the table student, so it will be gone. Okay, which means the student table cannot be seen once you drop that. Remember, okay? Create is going to add a table into the database, and drop is going to remove the table from the database. Then alter means to change a table. Okay, what do we do here? You see, we say alter, then we say table. Okay, then R is the name of the table. Add what? Some attribute with some, you know, domain. Okay, so let's say to the instructor table, I want to add, for example, his age, because age is not there. In there we can see, so I can say alter table instructor, add age, and it will be small int, for example. Okay, then if, let's say, you already have data, and then you change the table, you add a new record, so you see the existing tuples in the relation are assigned null. The age will be null for those instructor data which is already there. Okay, so that is how a null is introduced, because a new, you change the type of table, you know, some attribute is added to the table. Yes, Seham.
For add the new record in insert, I can add just one student, full record.
Hmm.
But what about delete? Just delete all tables?
Okay,
So it
yes,
needs.
okay. So we will use a condition, just wait, hopefully it will come, that this is good. You have asked a question. Let me add the capability to write something. So what we were discussing is that the ID, okay, we have y, that instructor.id and teachers.id, because we know they both refer to the ID of the teacher or the instructor. Okay, in the teachers, it is a foreign key, and in the instructor, it is the primary key. Okay, so what we do is that we are looking that this ID must exist also in the teachers. Only then we know that this teacher is teaching that course, for example. Okay, let's say the course CS101. So when we do some practical examples, then you will understand that why we do this equal. Okay, and also let's say here we have an additional condition, just not just instructor.teacher's ID, but we are only looking for those who have in the art. Okay, so all the instructors from the art department. Okay, then the rename operation, we studied this in the calculus, relational calculus. The SQL allows renaming relations and attributes using the as class. So old name as new name. Okay, this is the same thing as we explained before. Like here we see that select distinct t.name. Now what is t? This is interesting. Okay, what is t? You can see here after from instructor as t. So we rename instructor as t and we write t.name. Why? Because it makes it simplify. For example, instructor is, let's say, a big right. If you write again instructor, 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 then it will become difficult, let's say. So we will write instructor as t. So when we say t.name, it means instructor.name. And instructor st and instructor.s. Okay, this is interesting. Now we have the instructor st and instructor ss. What does it mean? It means that we are taking the same instructor table but in two different ways. Okay, so t.salary is greater than s.salary and s.department name is equal to computer science. Why do we need something like this? Because if you see the query, it says that find the names of all instructors who have a higher salary than some instructors in computer science. What does that mean? Can you see that? What does that mean? Two conditions. Okay, so higher salary than some instructors in the computer science. So in the computer science, because it's the department name, so we say this s dot department name. Okay, if we don't use s and t, what will happen? Let's say we don't use s and t, then it will become select distinct name from instructor, okay, where salary is greater than salary. It will become like this. So that will be confusing. What is salary greater than salary? It will be confusing. We want that the salary is of all the teachers is greater than the salary of the computer science teachers. Okay, so the computer science teachers will have some salary, and the greater than computer science salary we want to specify as t dot salary. Okay, so I think it may be a little bit, or definitely it is confusing, that why do we need this, but you will only realize if you think about this, that without using this, without using t and without using s, as I explained to you here, that you will just write salary is greater than salary, which is impossible, which is not a logical statement. So you need to specify that I have two tables logically. Okay, you will say that one table is, let's say, t, the other table is s, and they both are instructor, but I give them the names as t and s so that I can do this comparison. Okay, so here I say that t dot salary is greater than s dot salary and s dot department name is equal to computer science. Yes, Siham.
Doctor, you mean we make name because we have that attribute or the table schema, it's for salary, and we want that attribute for salary?
No, what I want to say is that in the instructor table, what do we have? We have the ID, we have the name, we have the department name, and we have the salary, four things, right? So if I don't use T and S, okay, but I want to search that some salary, okay, I need all those teachers who have more salary than the teachers of computer science. Okay, so this will mean what I want is that I need all those instructors who have more salary than the instructors of computer science. Now see, we are making a comparison in the same table. So in the same table, you are making comparison of what? You are making comparison on one attribute only, which is salary, because you want to compare salary of some with salary of the sum. Okay, so how do you specify? That's why we think of this as two tables. Okay, in one table we will select only the computer science teachers, which is actually S dot department name is equal to computer science, this one. So S is the one in which we will, let's say, choose the computer science table. Then from T, we will compare it with S, and we will say that from T, give us only those in which the salary is more than S. Okay, so in that way, we will get, you know, this condition is T dot salary is greater than S dot salary. So this will compare the two tables on basis of salary, and it will return what? It will return only the names, because we have only the name of T. Remember, so if I say S dot name, maybe it give me incorrect result here because we are looking for T dot salary is greater than S dot salary. If I say it T dot department name, then it may be wrong because this salary first we are choosing on the basis of S dot department. So this is actually one condition. You know, T dot salary is greater than S dot salary, and the other condition is S dot department name is equal to computer science. So I hope that it makes some sense. Or once again, I will just say that today we are going to do the theory part. Next week, inshallah, after the exam, well, not next week you will have the exam, but after the exam, after 2 weeks, we are going to do some SQL operations, some hands-on, just like we did for pandas. So we are going to do same for the SQL. Okay, so that at that time, if you have any questions, you can ask me and we will resolve those issues. Okay, now we say that keyword as is option, so you can write here from instructor T and instructor S. Okay, so it's the same thing. Okay, self join. Okay, now this is interesting thing. You have a person and the person has a supervisor, and we want to say that find the supervisor of Bob. Okay, now here it's clear that the supervisor of Bob is Alice, but you also have the person Alice. Okay, the person is Bob and the person is also Alice, and the supervisor is also a person. Okay, so how do you do this? Find the supervisor of Bob, find the supervisor of Bob. That's interesting actually. You know, now the supervisor of Bob will be easy. How do you do this? How do you say? If you want to write a query to the first one, find the supervisor of Bob, how do you do this? Select Bob. Select Bob is what? Because we are not select. If you say select Bob, it is going to do the literal thing. It will do this. Let me see. Wait. If you say select Bob, I think it will be this. Select A. It will do like this. Yes, select person, not Bob. Yes, you will select the attribute. So you will select person, and you need to select person, or you need to select supervisor actually. Yes, select supervisor, because you need this thing. You don't need the person. Person we already know. So select supervisor from, let's say, this table where person is equal to Bob. Excellent. But here remember, person can be small or big, but Bob should be exactly the same. If you write Bob as small, okay, all small, it will not find it, because Bob B, the first B of Bob is capital. So this is very important. In the attribute names, okay, person P can be capital or small, these can be anything. But in the data, we need to be careful. It should be the same one thing. Also, when you say that Bob, so Bob should be in, you know, these double quotes, because it's a string. Okay. Now about these two, how are you going to find the supervisor of Bob? Okay, or can we find all the supervisors, direct and indirect, of Bob, which means the supervisor of Bob is Alice, then the supervisor of Alice is David, and the supervisor of David is Mary. So if you want to find all the supervisors, then it will return Alice, David, and Mary. Okay, all the three will be the direct or indirect supervisors of Bob. Okay, so we will see them how it can work. Just wait. Okay, it's easy, but we will see that. Okay, so string operations. What we have seen are attribute operations on attribute. Select this thing and then some conditions on attribute directly. So those attributes were like mostly integers, or even if they were string, we will just say equal operator only, that department name is equal to biology or department name is equal to computer science. But there are other string matching operators which are working actually on part of the string, not complete string. Okay, so it can be comparison on characters, or can be like part of first few characters, last few characters, or find something within the string. Okay, so there is an operator which is called like, which is very important operator. It uses patterns that are described using two special characters. Okay, one is the %, the other one is the underscore. So the % character matches any substring, and the underscore character matches any character. Remember, it means that % can be more than one. It can be 1, 2, 3, up to 10, let's say, characters, anything. And the underscore is exactly one character. See this difference. Okay, so underscore will mean one character. Let's see the example. Find the names of all instructors whose name include what? The substring DAR. So here you see, how do you write it? Select name from instructor where name like %, %. Why do we write % before? It means that it can be 1, 2, 3, any number of characters before DAR. And after %, it can be anything, any number of characters after the DAR. Okay, so what does it mean? We can have something, what are the possible things? We can have, for example, let's say dark, let's say. Okay, we can have darker, DARKER, because this is string, this is string. Okay, similarly, if we can have, for example, TARDAR, let's say. Okay, radar, for example. Okay, all these, and radar, rar, dar, r, for example, let's say. So they all have dar. Okay, within them. Here is only one character, here are more than one, here is two, sorry, not anything after, but 3 before, 2 before, for example, and 3 before and 2 after, for example. Okay, but all of those, they have dar. What is before, what is after? Okay, it can be any number of characters. So if you want to match the string 100%, for example, okay, so you say like, because why do we say %? Because % is actually a special character. You see in the example dar, okay, we have %, but if you find 100%, so it should not be confused, this % within a string, you will use this backslash. Okay, this is backslash. So the escape backslash, in the above we use backslash as the escape character. This is known as escape. Okay, so escape means that we should not consider this part of the query. We should be a special character, which means that % is there and you want to search for person. Okay, so this is special condition. Just an example to tell you that if someone has a problem that why do we use %, so if you are searching for 100%, so you will use the escape character. And this escape character we also use, you know, in C, C++, Java, Python, etc. For example, you know, \n. What is that? \n in C, C++, or Java. Similarly, \t. Okay, that is for new line or tab. Okay, there is \s for a string, etc. So they are known as the escape characters, which are not, you see, not directly part of the string, but they need a special interpretation by the compiler. Okay. Then if you are looking for patterns, then remember that they are case sensitive. This is important. Okay, which means that small and big, they will be different things. So some examples, if you search for intro, you say like intro %. For example, in the last one we had select name from instructor where name like % this. You can say select course from you know, courses where course a name like intro %, like this. So it will match any string beginning with intro. So introduction to computer science, introduction to databases, introduction to Python, everything, it will be matched. For example, all those courses will start with introduction. Remember, start, which means that nothing before this. Okay, but if you have something like this, then it can contain fundamental of computer science or computer science solutions, let's say, or computer algorithms. Okay, computer graphics, all those things will be covered by this string. Okay, then the third example is underscore. 3 underscores will match any string of exactly 3 characters, because each underscore means exactly one character. Okay, 3_ matches any string of at least 3 characters. So it means that it will be at least 3 characters. It can be more because this can be 0 or more, this %. Okay, so _3 will have at least 3 characters, and there can be more than 3 characters, and so on. Then there are other operations such as the concatenation, when you combine strings, and converting from upper to lowercase and lower to uppercase, and finding string length of a string, and extracting substring, etc. Okay, so they are the operations which you can search easily on Google, etc., and SQL manuals, and you will find them. Okay, then there is the ordering of tuples. You want an order, and that's also something which is important sometimes. For example, in the pandas, lab, we wanted to order the result by grade, the numbers, total marks. Okay, so in one way you can either have ascending order or descending order, and we did that. So you have the recording with you, you have the notebook with you. You can see that there we had a property that ascending is equal to false. For example, when ascending is equal to false, it was doing descending order. When ascending is equal to true, it will be doing ascending order. Now here, when you don't specify the ascending or descending, for example, select distinct name from instructor order by name, so it will sort by name. Okay, and we may specify descending for descending order or ascending for ascending order. Okay, so the default is ascending order, which means that those instructors whose names start with A, they will come before those whose names start with B, and so on. Okay, so default is ascending if you don't write, but if you want the reverse, descending, so you will say order by name and then DESC, which means descending. And you can also sort on multiple attributes. What does that mean? Why multiple, and how is it possible? Because sometimes, let's say, if you sort on department name, for example, so many instructors, they will have the same department name, computer science. So within the computer science, if there are many faculty members, then the ones whose name come, let's say, before in the alphabets, start with A, it will come before, and the one which starts with B, etc., they will come after one. So within the department, first there will be selection. So for example, the people of biology, they will come before computer science. The people of computer science, they will come after chemistry, because chemistry is CH. So first will be biology, then will be chemistry, then will be computer science, then will be finance, for example, then will be physics, and then will be, let's say, zoology at the end. Okay, arts will be top. And then within the arts department or computer science department, if they are instructors, they will be sorted based on their name, the second thing. Okay, then SQL includes a between comparison operator. That's also interesting. Okay, so let's say some range between some things. Here is the example. Find the names of all instructors with salary between 90,000 and 100,000. So the salary must be greater than and equal to 90,000 and less than or equal to 100,000. So you will use this between this and this. And this is very important because you have used and also, and you have used between. Okay, so these are for integers. Now what if you do for other things? Here is tuple comparison, which we say that select name and course ID from instructor and teachers, where instructor.id and department name is equal to teachers.id and biology. So what are we doing here? It will return, of course, the name and the course ID. Okay, that's what we see from the select clause, but it will say what? It will just see only those for which the teachers table contains biology. Okay, so only those instructors who are from biology department. Okay, so this is one way. And if you start like this, then you will see so many things. Okay, but I hope that it's not difficult. Okay, and don't be afraid about the exam. I'm not going to ask something very difficult thing which will make you confused. Okay, it will be quite easy, just logical things. Okay, set operations. We already understood what is a set. Okay, here is an example. Find courses that ran in fall 2017 or in spring 2018. Okay, so the query is select course ID from section where, because section contains these things, it contains the semester and year. So from section where semester is equal to fall and year is equal to 2017 union. Now this is interesting. We have union, select course ID from selection where semester is equal to spring and year is equal to 2018. So both of these, you know, they are actually one query, but it has two parts, two selects. And between the two selects, we have the union, and you know union, it had. Okay, so the condition is different, although they are both from section. But the first one is that semester is equal to fall and year is equal to 2017. In the second condition, the second clause of select, okay, you have the spring and 2018. So it gives you this thing. Okay, if you can also, you know, write something like semester is equal to fall or semester is equal to spring and equal to 17 or year is equal to fall, something like this. But will it make exactly the same thing or not? You need to think about this. Okay, because maybe here, for example, you are clear that you need only fall 2017, but if you make all R, so it will also give you example of spring 2017, which you don't want. If you make R on fall or spring, okay, semester is equal to fall or semester is equal to spring and year is equal to 2017 or year is equal to 2018, so it will also give you fall 2018 and spring 2017, which you don't want. So that's one way in which you can exactly specify, you know, exactly fall 2017 and spring 2018, because you have two conditions in one query and two conditions in another, and that's where the union is very important. Here is another example. Find courses that ran in fall 2017 and in spring 2018. Now before it was or, now it is and. Okay, so what do? We have intersection. Okay, there was union, now it is intersect. The rest is same. Okay, so the, let's say, database, it was, you know, let's say in both fall 2017 and spring 2018, that then it will appear. If it is not in both, only in one, then it will not appear in this case. In the first case, if it is in any one, it will appear in the result. So that is the intersection or intersect. Then the third one is except. What is except? You remember the minus thing, okay? The subtraction. So select here, find courses that ran in fall 2017, but not in 2018. So only in this set. So you have two sets. This set, which will have spring 2018, and another set, 2017. So the set is returned by the first one, and second one is returned by the second one. But you minus the second one from the first one. So it will contain only those which are only in fall 2017. Any course which is also in spring 2018, it will be removed. Also notice that when we write the numbers, we don't use the quotes. Here, spring, fall, we use the quotes. Why? Because these are strings. So with string, we must always use, you know, the quotation, single or double quotes, and with numbers, we will not use it. If we use, you know, numbers, it means in string, in quotes, it will mean that the number is actually a string, although it is like a number, but that will be a string. Okay, and it's possible sometimes you will write numbers as strings for various reasons. Okay, so you should know when to use string and when to use numbers. Okay. Okay, so we have seen the set operations union, intersect, and except. Okay, so these will, you know, remove the duplicates. If you want to use the duplicates as well, then you will use the all keyword, which we have already seen. Select all. Okay, so union all, intersect all, except all, which will also include the duplicate. What does that mean? Well, we need to actually do this in hands-on. Okay, null values. We know that it's possible for tuples to have a null value, which is denoted by null, like this, and null signifies an unknown value or a value that does not exist. So we don't know. No, exam is everything. Just let me finish the slide, then we will discuss. Okay, so the result of any arithmetic expression involving null is null. So if you add something to null, it will be null. If you you know, select something from null, it will be null, and so on. So 5 plus null will be null, and the predicate is null can be used to check for null values, which we already did that, for example. Okay, is null was a function in pandas. So when we wanted to check the null values, we say what we said, that df underscore marks dot is null. So it will return true or false for every cell. Okay, for every column and row, what are the null values? Okay, so if it was null value, it will be true. If it was not null value, it would be false. And in this way, you can actually select only those values which are null, or select only those values which are not null, for example. Okay. So if you want to find all instructors whose salary is null, which means that it is not known, or let's say they are new instructors, so their salary is not yet declared. So you can say select name from instructor where salary is null. Very simple. Okay. Similarly, is not null if you want to say that something is not null. Okay. Then SQL treats as unknown the result of any comparison involving a unknown value. Okay, other than predicates is null and is not null. So if you say example here is 5 is less than null, or null is not equal to null, or null is equal to null, so it will be what? It will be unknown. Okay, now what does it mean? Here is some details. I just leave it to you. This is some practical example. Okay, very quickly, the predicate in a where class can involve Boolean operation, where this is equal to this and that is equal to that, for example, or not. Thus, the definition of the Boolean operations need to be extended to deal with the value unknown. So we will treat unknown. So unknown with anything, unknown and true is equal to unknown. Or with false, this is very important. Like, so if something is true and you have and unknown, it will become unknown. If something is false and unknown, it will be false. Unknown and unknown is unknown. Similarly, unknown or true is true, unknown or false is unknown. This is very interesting. Okay, this is something just very specific to some examples. Okay, so we will stop here.